Hi everyone, this is 𝗟𝗲𝗃𝗲𝗹. Welcome to Smart Interviews YouTube channel, your one-stop solution for all the tech interviews. Today we are here to discuss the first three problems of the latest Codeforces contest, Codeforces Round 1009 Div 3. Without any further delay, let's start. So the first problem is draw a square. Reading the problem description, the pink soldier has given you 4 distinct points on the plane. The 4 coordinates are -l,0, r,0, 0, -d and 0, u, where this l, r, du are 4 positive integers. Please determine if it is possible to draw a square. Okay, with the given 4 points as the vertices. Let's see the input format. Each test case contains 4 integers l, r, du. Output format. If you can draw a square using these 4 points, output yes. Otherwise, output no. Okay. Here you are given 2 test cases. First test case, l, r, du are 2. Is it possible to draw a square with these 4 points, with these coordinates? If it is possible, we need to print yes or else no. So let's first understand this. This is -l, 0. If I consider this as my x-axis, right? And if this is my y-axis, then this point is 0, u. This is r, 0. This is 0, -d. We need to check if it is possible to draw to form a square with these 4 coordinates, right? To form a square, all these 4 sides must have equal distance, right? So I need to get the distance here for all the 4 sides and check if they are equal or not. So what I will do is, I will apply the distance formula. If this is x1, this is x2, sorry my bad, this is y1, this is x2 and this is y2, then the distance x2 minus x1 whole square plus y2 minus y1 whole square. So here, if we apply that, distance will be root over l square plus r square, right, for this side of the square. For this side of the square, what is the distance? Root over, this is u square because this is u, right? And here, for the second side, the distance is u square plus r square. For the third side, it is root over r square plus d square. For the fourth side, it is root over d square plus l square. Now, these 4 has to be same, right? That is nothing but root over l square plus u square must be equal to root over u square plus r square, right? If we square on both sides, l square plus u square must be equal to u square plus r square. This is nothing but l square must be equal to r square. This is nothing but l must be equal to r, because it is given that all the 4 are given as integer, positive integers. So because of that, l must be equal to r. Now if I do the same thing for these 2, I will get u must be equal to r. If I do for these 2 points, I will get R must be equal to L. If I do for the first and the last, I will get D must be equal to U. That is nothing but, if you use these four equations, if you see these four equations, we get that L must be equal to R, R must be equal to U must be equal to D, right? So all the four has to be same. All the 4 points has to be same. Now, if we go back to the problem statement in the test case here, the first test case is all the 4 points as 2 and we have printed yes. The second test case, all the 4 points are not same, printed no. Let's try to code it up. Taking scanner class, creating an object, take the input, first line contains T, for each test case we need to take 4 integers. As the 4 points has to be same, it doesn't matter in which order we take the input, all the 4 has to be same at the end. Now, if L is equal to U and U is equal to R and R is equal to D and D is equal to L, then I can print yes. Else I need to print no. Submitting the code. Submitting code 1. Accepted. The next problem is the third side. The pink soldiers have given you a sequence A consisting of n positive integers. You must repeatedly perform the following operation until there is only one element left. Okay, let's see about what are those operations. Choose two distinct indices I and j. Then choose a positive integer value x such that there exists a non-degenerate triangle with sides as ai, aj and x. Okay, here you are given a sequence of elements, right? So let the sequence of elements be a1, a2, a3 and so on an. You need to select two distinct indices I and j. Let this be I, this be j. Then choose a positive integer value x. You need to choose a positive integer value x such that there exists a non-degenerate triangle. This means a valid triangle which has a positive area. Even if you see here, they have given you some information about non-degenerate triangle, where if A, B, C are the sides of the triangle, A plus B has to be greater than C, A plus C has to be greater than B, B plus C has to be greater than A. Finally, remove two elements AI, AJ. So I can remove these two elements AI, AJ and append x to the end of A. So at the end I need to append x. So what is happening here? If there are n elements in this list, we are removing any two elements and adding an element. So overall one element is being removed, right? Please find the maximum possible value of the only last element in the sequence. So when you do this for n minus 1 times, you will have only one element in the array in this list. So you need to find the maximum possible value of that last element in this sequence. You are given t number of test cases. Each test case contains two lines. The first line contains n, single integer n. Second line contains n integers a1, a2 and so on an. It is also given that sum of n over all the test cases does not exceed 2 into 2. Okay. For output the maximum possible value of the only last element on a separate line. Okay, let's see the sample test cases. Here you are given 4 test cases. First line contains size of the array. Then the only element is 10. So as the only element is 10, we need to print 10 as the output. Yes. Here you are having 3. That means 3 elements in the array. You can select any two elements. And you can add x and remove these two. Where these two elements, array of I, array of j and x, has to form a degenerate triangle. Okay, just read the explanation for the second test case. You are taking 244, 353 and you are appending 596. Then your array becomes 998 and 596. After that, you are selecting these two and you are adding 1593 and your A is only having 1593 and this is the maximum possible value and he printed it. Pause the video here, see the solution. Let's try to understand the problem with this example. If I pick these two elements, I need to add x to this array and remove these two if and only if this x satisfies 3 conditions, right? Which are ai plus aj has to be greater than x, ai plus x has to be greater than aj, and aj plus x has to be greater than ai, right? These 3 has to satisfy. Now my question is, can we do this with just one of these instead of these 3? Can we make it work with using only one equation from these 3? For example, if I take these two elements as my I and j, then do I need to check all these 3 conditions? 5 plus 4 greater than, suppose I am adding x as 8, greater than 8, and 8 plus 4 has to be greater than 5, and 8 plus 5 has to be greater than 4. Do I need to check these two again? We can only check this one condition, right? Because if we take the minimum, the smaller elements on the left side and the greater element here, if this condition satisfies, the remaining two will also satisfy, right? So what I will say is, if ai, aj are minimum values, I don't need to check these two conditions. If the first one is satisfied, it is well and good. So now let's see what if I pick two elements. If this is my number line, if this is ai, if this is aj, I need to pick x, right? My x can be smaller than these two. right? It can be somewhere here. My x can be in between ai and aj, which is here. The value of x can be greater than ai and aj. It can also be here, right? So if it is less than both ai and aj, which is on the leftmost part, then x plus ai has to be greater than aj. We just need to verify this one condition. If it is between ai and aj, then I need to check this condition. ai plus x has to be greater than aj. If it is greater than ai and aj, I need to check this condition. ai plus aj has to be greater than x. Okay. From these three equations, what can we say about x? What can we say about x? What is the minimum possible value and maximum possible value for x? From this, x is greater than aj minus ai. From this, I can say x is greater than aj minus ai. From this, I can say x is less than aj plus ai, right? I am sending ai this side, ai to this side. This side is already on the right hand side, so I am just changing it the other way. So from this, what can we say about the range of x? That we can pick the value. X has to be, these two are same, right? X has to be greater than aj minus ai. And from this, we can say that x has to be less than aj plus ai. So it has to be greater than aj minus ai. It has to be less than aj plus ai, right? So x must always be in the range of this, where this and this are not included, right? I'm just changing this. I can write it as x belongs to aj minus ai plus 1 and change this symbol to this so that I can include this. Similarly, aj plus ai minus 1 so that I can include it, right? Now what is our objective? We want to find maximum value of x possible at the end. So to get the maximum value at the end, I also need to get the maximum value at this instance. So what is the maximum value I can pick from this? It is this. The maximum value we can pick is ai plus aj minus 1, right? So let's see this with the example. With this example, let's try to understand. Suppose I am picking this as I, this as j. I need to select x such that it will be sum of these two minus 1. So I need to remove these two and add 8 to my array, right? And then if I am picking this and this, I need to remove these two and add 8 plus 3 minus 1, which is 11 minus 1, which is 10, right? Now I need to pick these two. I am picking these two, I and j, and I am removing them and adding 10 plus 2, 12 minus 1, which is 11. Again, if If this is my I, this is j. I'm picking these two, removing them, and I need to add 11 plus 1 minus 1, which is 11 again. And we only have this one element in the list or the array. So I need to print this. What was the answer for this test case? 11, right? So what are we doing? If the elements are A0, A1, A2, A3 and A4, what are we doing? I am picking these two, A3 plus A4, and I am subtracting a minus 1 and adding to it. Now I am doing the same process for these two elements, right? For these two elements. So I need to add A2 to this. I need to subtract minus 1 to this. Done till here. Now I need to pick this and subtract minus 1 again. Subtract minus 1 again. And I need to pick A0. Subtract minus 1 again. So what is this overall? A0 plus A1 plus A2 plus and so on, plus an minus 1 from 0 to n minus 1 index. We are adding all these elements. And how many ones are we subtracting? N minus 1, right? So this is nothing but sum of the array A. So the overall answer is sum of the array A minus n plus 1. Sum of the array A minus n plus 1. Writing the code for it. For t times, we need to take the n size of the array. Then I need to take the array. After this, I need to find the sum. For that, we can do it while taking the input itself. Taking int sum equal to 0, because it was given that sum of all the elements will not exceed 2 into 10 power 5. We can store that in integer range. This is array of I. After that, I need to print sum minus n plus 1. That's it. We can submit this. Submitting code to. Third problem is XOR and triangle. This time, the pink soldier have given you an integer x, where x is always greater than or equal to 2. Please determine if there exists a positive integer y that satisfies the following conditions. Y is strictly less than x, and there exists a non-degenerate triangle with the sides being x, y and XOR y. We have already seen this, right? Non-degenerate. That means it has to form a triangle. Now, each test case contains an integer x. The range of x is 2 to 10 power 9. For each test case, print one integer on a separate line. If there exists an integer y satisfying the conditions, output the y. Otherwise, output -1. Clear with the problem statement? Let's check the sample test cases. First line contains t number of test cases, and here the problem says that you are given x, which is always greater than or equal to 2. You need to find a y such that this y is always less than x, is always strictly less than x. X, y and x XOR y has to form a triangle. That means x plus y has to be greater than x XOR y, x plus x XOR y has to be greater than y, y plus x XOR y has to be greater than x. It has to satisfy these three conditions. Pause the video here. Try to think of a solution. Let's discuss the solution. So the first thing that got into my mind when I saw this x plus y and XOR y is a formula, which is x plus y is equal to x XOR y plus 2 times of x and y. So let's try to substitute this relation into these three and let's see what we get. X plus y has to be greater than x XOR y. So I'm writing this RHS in this LHS. X XOR y plus 2 times of x and y has to be greater than x XOR y. If I simplify this, I will get x and y has to be greater than 0. This is our first relation, right? From this, let's use this and try to get the second one. X plus, let this x plus y, let this XOR y be as x plus y minus 2 times of x and y times of x and y, and which has to be greater than y. Simplifying this, we will get x minus x and y has to be greater than 0, which is x has to be greater than x and y. This is relation number 2. Let's try to substitute in third and get relation 3. XOR y is x plus y minus 2 times of x and y, which has to be greater than x. So y minus x and y has to be greater than 0. Y has to be greater than x and y. The third. So using these three, what can you say about the value of y? Because x was given to you, right? So using these three, what can you say about y? Pause the video and think about it. What we can say is, here x and y is greater than 0. X and y is greater than 0. That means if x is having some bits like this, and let y be any number which is less than it. So as it is less than, all the remaining bits on the MSB sides will be 0, right? So at this point, here we need to have at least one set bit which is also set in x. right? To have x and y as greater than 0, we need to have at least one set bit here which is also set in x. Clear with this? Clear with this? You need to have at least one set bit in y which is also set in x. This is what we got from equation 1. Let's see equation 2. What can we say about it? X has to be greater than x and y. It is not dependent on y. So let's see equation 3. We can't get much information from this equation 2. So let's see equation 3. Y has to be greater than x and y. Y has to be greater than x and y. Suppose if x is some number again, if y is a number which is less than x, we can't have any set bits here. From here we can have. Now, if the result is x and y, this x and y has to be less than y, right? This x and y has to be less than y. So what can you say about y? It has to be less than y. X and y has to be less than y. What can we say about it? Can I say y must contain at least one bit which is set and which was already set in x? Can I say y contains at least one bit which is set and which was unset in x? The previous one is, I will write the 2 here. I will write the 2 one. First one, when we were discussing equation 1, we got that y need to have at least one set bit, which is set in x, right? From equation 3, we got that y contains at least one set bit, need to contain at least one set bit which was unset in x. That means from these zeros, at least one of them has to be 1, right? So if I take this one as 1 and all the remaining as any of the others, I will definitely have this y as greater compared to this x and y, right? Try to take some examples and understand this 1 and 3. Now I can say that if these two conditions are satisfied, if we can find a value of y with these two conditions are satisfied, then I can form a triangle, right? So can we form a y with these two conditions satisfied every time? Let's see if it's possible or not. For this example, I need to set a bit which is set in x. So I will find the first set bit, which is this, change it as 1. I need to keep it as 1. Then find y. In y, we need to find set bit which was unset in x. So I need to find unset bit here, which is here, and I need to make it as set, and I can leave all the remaining, right? So if I can find such a value of y, I can form a triangle, right? But is it possible to form a y always? No, right? That is why he said print -1 if it is not possible. So we need to find the cases when it is not possible. When will it be not possible? If there is no unset bit in x, right? Suppose this is x. This is the value of x. What can be the value of y? What can be value of y? First I need to find unset bit, which is this. I need to change it to 1. I need to find set bit and keep it as 1, and all the remaining can be zeros. But is this a valid y? Is this a valid y? Is this a valid y? No, right? This y is greater than x. According to the constraints, x has to be from 1 to y has to be from 1 to x minus 1. Right? So we can't have this value. So when x has number of set bits as 1, number of set bits as 1, we can't form a triangle. Is there any other way? Suppose if the value of x is 0, 1, 1 and all ones, what will happen? I need to find a set bit and make it as set. So I made this set. I need to find unset and make it as set. I will find unset which is here. I need to make it as set and all the remaining as zeros. Is this a valid combination? Same thing, right? Y is greater than x, but y has to be within this range. So what is this? X called, how can we write this x? How can we write this x? We can write it as, if we find unset bit, at the, or we can simply write it as, we can simply say this as, which is of the form 2 power x minus 1 power x minus 1. This is of the form 2 power x minus 1. Not exactly x, 2 power some set bits minus 1. So in these two cases, we need to print minus 1. In all the other cases, we will print the value of y, which is following these two conditions, this and this. Let's try to code the third one. First line contains t, number of test cases, for t number of times. Take the value of x. Here this, if it is of the form 1 and all zeros, or if it is of the form 0 and all ones, then we need to print minus 1. So if of the form 1 and all zeros, it is power of 2. So I will write a function power of 2 and pass x. If this returns true, then I need to return true, print minus 1. Now if it is of the form 0 and all ones, then it is of the form 2 power x minus 1. So what I will do is, I will add 1 to it, it will become 2 power x. So I will check if x plus 1 is of the form 2 power x or not. If it is, then I will print minus 1. I will print, I will write this function find y and I will pass x, and let's see what it will return. Now let's try to complete this power of 2 function. If it's the form 2 power x, then n and with n minus 1 will be 0. So what I will do is I will return n and with n minus 1 is 0 or not. And now let's try to write find y function. I'm taking copy of x. Let's try to count the highest set bit. What I am doing here is, if it's of the form 1 and all zeros or 0 and all ones, then it will go into the if condition. If it's not of that form, then definitely we have a 0 and 1, right, which we want. So what I will do is, I will try to find the highest set bit. First let's find the highest set bit, HB, while HB greater than 0, HB equal to HB, right shift by 1. And count plus plus, I'm counting the highest set bit position. Once I find that, I will remove 1 from it, that is count minus 1, and for this value I will find 2 power of it. 1 left shift of this will be 2 power of count minus 1. For this I will subtract minus 1. This is my y value, this is one of the possible y value. Getting code 3. That's it for today, guys. Thanks for staying till the end. I hope you like the content. If you have liked the content, share it with your friends.